Hi, Paul here from Easy Composites with the final part in our Dark Ice project series where we're making this lightweight and indestructible sledge for a North Pole record attempt called the Dark Ice project. We started this journey by speaking to the expedition coordinator, Alex Hibbert, to find out exactly what he needed from these sledges. With that information, we were able to do the initial design and produce the pattern. We then went on to make the mould from that pattern, and then we did some rigorous material testing to establish the best materials that we could make these shells from. And then finally, in this video, we're going to be going on to do the resin infusion itself. So we'll be preparing the mould, applying a gel coat onto the mould, and then we're going to cut and prepare the materials. So that's the Kevlar and the core materials, before setting up the vacuum stack for a perfect resin infusion. So we're going to start off by preparing that mould. As with all composites projects, we need to start with the release agent, which is a chemical coating that will stop the resin of the part adhering to the mould. In this case, we're applying 6 coats of Easy release agent. You will see us using this release agent in most of our other videos. The application method is to wipe a thin film systematically over the surface. On a new mould like this, 6 coats will be applied. After this, only 1 coat between releases is required. If you're going to be spraying a gel coat, the mould flange will need to be masked using a flash release tape to keep it clean from any overspray. With the mould now fully prepared, we're ready to put down the gel coat, so we'll just take this now through to the booth. The gel coat we're using is our GC50 epoxy compatible polyester gel coat. This is specifically designed for use with an epoxy backing resin. Normal polyester gel coats can only be used if you're using a polyester or vinyl ester resin for the main infusion. The GC50 can be used clear, but in this case we want the part to be black, so a polyester pigment is added to the gel coat at 5%. As this gel coat is polyester based, it then needs catalysing with the MEKP catalyst at 2%. With the gel coat catalysed and mixed, it can now be transferred into a paper cup for the cup gun and sprayed. This cup gun is specifically designed for spraying gel coats, which are very high viscosity. They are also very easy to clean, as the paper cup is a disposable element. Although I've chosen to spray the gel, it's most common to brush apply gel coats, especially on smaller parts, and in the case of cosmetic carbon fibre parts, generally no gel coat is used at all, and the reinforcement is infused directly onto the bare mould surface. You may notice that there is an obvious problem with my process here. I'm spraying a black gel coat onto a black mould. When I made the moulds, the sledges were going to be yellow, however, a last minute change in sponsorship arrangements left me spraying these almost blind. However, with a methodical approach and careful inspection, spraying a consistent coat is still perfectly possible. The gel coat has now been left to fully cure. Now when it does cure, it cures without any surface tack at all, which is unlike a conventional polyester gel coat. This is part of its function and allows the epoxy resin backing to fully bond to the surface. I will stress that if you were to use a conventional polyester gel coat, you can't back that up with an epoxy resin. So if we move on now to the materials themselves, we're going to start by looking at core materials. Now we'll be adding a 3mm core in the flat areas of the part, and this will give us additional stiffness without adding excessive weight. The core material itself is 3D core. This is a PET foam core and it has a hexagonal pattern embossed through the surface. And this will allow the resin flow over the back to flow through the core material and fully impregnate the reinforcement behind. To prepare it, simply a case of cutting it to shape with a straight edge and a knife. The edges of the core material should be chamfered. This tapered edge will allow the layers of fabric to follow the edge without any sharp changes in direction and without leaving a bridge void that could lead to an inconsistent infusion. 3D core is manufactured in relatively small sheets, but joining them together is a simple process of breaking out the hexagons and nesting them together. This has no significant influence on either the infusion process or the structural properties of the part. With the core materials prepared, we're now going to cut the reinforcement itself. If you did watch our material selection video, you'll know that we decided to use Kevlar for the build of this sledge. So in the areas where we have the core, we're going to be running 2 plies either side of the core. And then in the solid laminate areas, we're going to put an additional 3 plies there to give it reinforcement in the high impact areas, and then 1 or 2 areas where there'll be even more localized reinforcement. Pulling a toe from the fabric gives me a quick guideline to follow with the shears. To cut Kevlar, you really have no option other than to use dedicated Kevlar shears. Conventional scissors will bind and will only make very, very slow progress. Our Kevlar shears have a specific grinding that make cutting Kevlar possible. If you do invest in Kevlar shears, reserve them only for Kevlar, as the more abrasive carbon and glass reinforcements will dull them very quickly. I'm going to begin the layout by positioning the first layer of reinforcement. So that's simply a case of rolling it out over the surface of the mould and getting an approximate position. With the first ply loosely positioned, I can now peel this back and then use the Fusion Fix spray adhesive to secure it tightly in place. Now I'm able to do that directly onto the surface of the mould because we've got a pigmented gel coat. If you were working on a cosmetic carbon part with a clear or even more likely no gel at all, I wouldn't advise using the Fusion Fix spray adhesive for that application because it can lead to very slight milkiness and imperfections on the surface. After the first ply, on the subsequent backing plies, you can use it as long as you're using it lightly and it won't cause you any problems. When you lay the reinforcement, you need to position it as tightly into the mould as you can. This reduces the possibility of bridging in the corners and ensures consistency in the part. Joins in the reinforcement should overlap to prevent weak points. In the case of this part, we allow a fairly large overlap as we actually want the additional thickness of the join in the corner. This is where the sledge will receive most of the impacts. The second ply into the mould is simply a repeat of the first. So that's the first two plies for the outer skin laminated. The next layer in this case is the core material. So that's going to be sandwiched in between the Kevlar and give us that additional stiffness in the flat areas. So the core materials are positioned in the areas where we want the most stiffness, but not necessarily where they'll be subjected to a lot of impact. So the main run of the base and the sides and the rear. Around the front and the nose here, these are going to be encountering frequent impacts, likewise on the shoulders. And also the runners themselves are bearing nearly all of the load of the sledge. So in these areas, instead of having core material, we're going to go with a solid laminate to make it particularly tough. The additional reinforcements are butted up to the core material, and then the inner two plies are laid over this. The entire layup of this sledge is a very quick and clean process and was completed in less than an hour. With all the reinforcement now in the mould, ready to start looking at the infusion itself. So we've got the consumables here. We've got a peel ply, mesh, the vacuum bagging film, sealant tape and some of the ancillary items. If you are just starting out in resin infusion, pretty much all of the materials that you'll see us using from this point forward do come conveniently in our resin infusion starter kit. So let's have a look at the materials and how they work. The first layer is a peel ply. Now the purpose of a peel ply is to allow the resin to freely flow through it, but after the resin is cured, it can be peeled back and it will tear the rest of the consumables away from the part. Without this, the infusion mesh would stay permanently embedded in your part. So the infusion mesh then, that's the next layer in, and this is the material that allows the resin distribution. Without this, resin infusion really can't take place. And it works by creating channels with the bag bridging over the top, creates channels that the resin can flow down before flowing through the peel ply and into your reinforcement. To get the resin into that mesh, we're going to use a resin infusion spiral. Now this is essentially just a tube with a slit cut in a spiral fashion. So the resin will flow into that, down it very, very quickly, and then leak out through the spiral and into the mesh. To get the resin into the spiral, we have a reusable resin infusion connector. You can't use a conventional through bag connector, for instance, because this will all get surrounded by resin and it would ruin those parts. So these are silicone and they can be torn out from the cured resin. Then we have a conventional vacuum bag over the top of that, and then that is sealed to the perimeter or the flange of the mould. Now with resin infusion, 9 times out of 10, you will be sealing to the flange of the mould. So unless you're working with a completely flat surface, you'll also have to include pleats. Now this is where the bag comes up and goes over, and it just gives you that excess bag, which will mean that the bag can follow all of the contours in your moulding without having to bridge or stretch. So let's get started. First thing I need to do is clean the flanges of the mould, because we've got some overspray, we've got stray fibres that have come out of the Kevlar. And if, say, one of these very, very fine strands of fibre was to get underneath the sealant tape, that will cause a leak and that will cause a problem on your infusion. So we're going to just go around with a microfiber cloth, making sure that the area that we're going to tack down the gum tape onto is completely clear of any contamination. I'm putting the gum tape down now at this stage before any of the rest of the consumables, because this is the point that I know that it's completely clear and completely clean. When all the peel ply and the other materials go on there, it would be more difficult to be certain of the cleanliness of the seal. The peel ply is now laid into the mould. In many ways this is a very similar process to laying the reinforcement. Whilst overlaps and joins in the peel ply are absolutely no problem, gaps would be. So you must ensure you have complete coverage. Spray tack can be used to position the peel ply if necessary. The peel ply should be sized slightly larger than the underlying reinforcement and secured to the flange using flash release tape. The mesh can now be placed. This should be sized slightly smaller than the peel ply. Spray tack doesn't hold this, and even the flash release tape doesn't tack it very well. However, duct tape adheres adequately, so small tabs should be used to secure it in place. As these tabs are on the back of the mesh, they will have no influence on the infusion going on underneath. We now need to consider where we're going to position the resin feed lines, vacuum points and distribution spiral. There are a few simple rules you can follow to help optimise the flow of the resin. So let's look at a few examples as to how you might set this up. Probably the most obvious or intuitive way that most people would think would be to run a spiral down one end of it with a resin feed line, and then over at the far end run the vacuum point. And in this case we'd be asking the resin to flow for nearly 3 metres. Now if we did that, that would take probably around about 4 hours or so to infuse, which is much longer than the pot life on our resin. So we've got to think of ways to reduce that. The trick is reduce the distance it needs to flow from the spiral. So we could immediately reduce that by half, which would make it 4 times faster, just by running the spiral down the long side and then allowing the resin to flow across the width. So it's going half the distance, about 1.5 meters, and that'll be probably 4 times quicker. So we might be looking at something an hour and a half. So how can we improve that further? Well, if we ran the spiral not only down the side here, but we also ran around in a U shape, right around the perimeter, then we're only asking the resin to flow from the spiral down half of that distance. So now we're 4 times quicker still. So at that point, we're probably looking at something like 30 minutes. It depends. The main restriction in that situation is going to start to be the connectors. We can go even faster still by running additional spirals down the centre, another one here, and then we are only asking it to flow for around about 250-300 millimetres. And that's going to start bringing our infusion times down into the minutes. So the main thing you're looking to do is reduce the distance it has to flow from a spiral. A rule of thumb on that is 500 millimetres, so half a metre of flow distance. If you can keep it under half a metre, your infusion times generally will be very quick. The next thing is the resin feed lines. If you're doing an infusion that's going to take 10 kilos of resin, this will be the point where you get the most restriction. The small hose that feeds in and the resin feed line. These particular connectors that we're using today, we would say normally around about 2 kilograms of resin is about an appropriate amount to run through each one. So if you had a 10 kilogram resin mix on a very large part, you might need 5 of these. In the case of this part, I think we're going to need 2 inlets because we're going to be running around about 4 kilograms of resin into the part. When it comes to positioning the vacuum ports, the way to decide where they go is the point which is furthest away from both any resin inlets and the spirals. And that way it will converge at that point last, or at least that's the theory. If you've got a complicated shape and you can't perfectly work out where that's going to be, put more in. It's no problem to wait for the resin to hit one of these. As soon as it does, you can clamp that one off and you can have another one. You know, in the case of a Y shape, for instance, you could have 2 vacuum ports in 2 different locations. One thing that is worth noting if you're trying to run the spiral, or you need to run the spiral on the surface of the part, on thin cosmetic laminates, predominantly talking about carbon fibre here, the bridging of the bag over the top of this spiral will slightly imprint on the carbon, and so you will get a slight visible line. Now if it's a very flat panel, you'll see it. So you'll see this slight reflection in the carbon, and that would be a cosmetic imperfection. So wherever possible on cosmetic carbon parts, keep the spiral off the edge of the part, which is why for most things you're generally running in this U-shaped format, and you can go quite comfortably up to panels that are 1 metre, or if you stretch the rules a little bit, maybe 1.5 meters wide. So we're just going to secure this in place now using duct tape, and it's important that you position the spiral on top of the mesh. If it's off the mesh, the resin can't flow out of this and into the mesh, so it needs to be sat on top of your mesh all the way around the perimeter. Let's now look at the vacuum port location. So we've got it positioned here, which is the point which is furthest from the spirals, and in theory, that's the last place that the resin will get to, which is where we want it to be. I've also included something called a resin break. Now, that is where we've stopped the mesh short of the connector. And the reason for that is, if we were to put that connector on top of the mesh, and something unforeseen happened in the infusion and the flow path, and we ended up with the resin hitting this connector before, say, it infused these corners, so it's coming up in an arc like this, we would have to keep the vacuum running and keep drawing resin off just to maintain a vacuum on the dry areas. But by putting in this resin break, we have a situation where the resin will flow up to here, and if it does get to this point first, it is just like the resin's hitting the brakes, so it slows right down about 20 times. And that will give us time for the resin to start leveling out at the top here, and we'll be maintaining a vacuum into these dry areas. We're now ready to go on with the vacuum bag itself. Now, clearly, if we were to just stick the vacuum bag straight onto this sealant tape and bridge across here, we wouldn't have enough bag to stretch down and contact all of the contours of the mould. So we need to get that additional bag onto the part. So to work out how much additional bag we need, if we just measure across the surface the mould here, we've got around about 1.8 metres, and then if we were to measure straight across, we have a metre. So we've got an additional 0.8 metres or 800 millimetres that we need to add into the bag. The way we do that is by putting in pleats into the seal so that we have the extra bag. So to get the 800 millimetres, if we did 2 pleats that were 200 millimetres tall, that will give us the 800 millimetres. So 200, 400, and then doubled up, that's your 800 mil. Now, I wouldn't go that close because that's exactly the amount of additional bag we need. So instead, I'm going to make sure we've got plenty of bag and double that up. So I'll be running 4 pleats at 200 millimetres in this width. So that'll be one here, 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 and here. I always like to put a pleat in the corner because that means that you've definitely got some bag going into the length and into the width and reduces the chance of getting bridges just across. If we had a pleat, say here and here, this bit could still stretch sort of tightly across that corner. So we're going to get on now and put the pleats in. Creating the pleats is very, very simple. Just tear off some of the backing off your gum tape. Take some more gum tape. So in this case, around about 400 millimetres to create a 200 mil pleat. Fold it over on itself, like so, leaving some little legs at the bottom. Attach that onto the other seal. And there we go, we've got a pleat.
With the pleats in place, we can now seal the vacuum bag to the mould. Resin infusion is completely merciless to the inexperienced when it comes to vacuum bagging. Even the smallest leak can cause a problem in the part, and so a slow and methodical approach is essential. General industrial hygiene and neat work really pay off here. I pay full attention to every millimetre of the seal as I'm applying the bag. It's much quicker to reduce the risk of a crease or a stray fibre when you're applying the bag than trying to find a leak later on. Unless you've been lucky and have managed to keep the vacuum bag perfectly square throughout the sealing process, it's likely that you will either need to extend or reduce the size of the final pleat. The hoses can now be connected. This is simply a case of piercing the bag, pushing the hose through and sealing with sealant tape, ensuring that the bag has no creases under the seal.
In between the part and the pump, we have a catch pot. Now, a catch pot is there to save the pump from damage. With resin infusion, it's very common to have the resin coming up through this line, and if it was to go straight into the pump, of course, that would harm the pump. So this is there to catch that resin before you clamp the line finally and switch the pump down.
The resin feed lines are connected in the same way as the vacuum line. Cutting a chamfer on the ends of the hoses helps to push them into the fittings and also prevents the tube from bottoming out and restricting the resin flow.
Here I'm going to tape these hoses onto this stick, and that's so that I can tape that into the bottom of the bucket and it will firmly hold these lines in the bottom of the bucket. It's very common, if you don't do this, for a line to fall out of the infusion and destroy what would have otherwise been an absolutely perfect part. We're now at the point that we can pull a vacuum on this. So to do that, we've first got to clamp these lines off, because obviously that is compromising the seal. So we clamp the resin inlets.
The vacuum can now be pulled on the bag. This is quite a simple shape, so positioning the bag is quite straightforward. On more complicated shapes, you should gradually increase the vacuum level and position the bag in a few steps. This ensures that the bag and material stack conforms as closely as possible to the mould contours. If you notice an area of bridging, then drop off the vacuum, reposition and try again. While the vacuum is pulling down, it's a good opportunity to take a lap around the seal, inspecting it and pressing it down further. If you're using a leak flow indicator, you're waiting to see this stop moving to show that the bag has been fully pulled down.
I've got the vacuum pulled on this bag, and as you can see, the leak flow indicator stopped spinning. That indicates that we've got a well-sealed bag. What it doesn't indicate though is if we've got a perfectly sealed bag. And there's absolutely no point in running a resin infusion unless you know that your bag is perfectly sealed. So to find that out, we're going to do something called a drop test. Now there are a few different methods of conducting a drop test. The simplest one is to clamp off the line here, just between the catch pot and the pump, wait for 45 minutes to an hour and see if this gauge noticeably drops at all. If it does, that means you've got a leak. The method that I'm going to use is a little bit quicker than that. Because we've got a leak flow indicator in the line here, I can clamp the line off as it comes out of the part, wait for 10 minutes and then remove this clamp. And if there has been a slight leak, there will be a surge of air that will run through and it will make the leak flow indicator spin, and you might also see a flicker on the gauge. Okay, so we're removing the clamp now. After 10 minutes, just crimp that straight. We've got no fluctuation on the indicator there, no flicker on the gauge, so I'm completely happy that this is a perfectly sealed bag. It's been a really interesting journey to get to this point. We started out with a design brief for the sledge, we've gone on to design the sledge and then make the pattern. Then we've made the mould from the pattern, we've done material testing to establish the best materials to make these sledges from. We've laminated all of the material into the mould, we've pulled a vacuum on it, we've done our drop test, and finally we're at the stage I'm sure you've all been waiting for, where we're ready to do the infusion itself. So let's get that resin mixed up.
Here we are mixing the IN2 epoxy infusion resin accurately and thoroughly to the specified ratio, like you will have seen us do in many other tutorials. In this case, we are mixing the entire amount of resin in one batch, but for larger or slower infusions, using multiple batches as the infusion progresses can help to ensure that you don't run out of pot life. Here I'm using the double pot method, so I'm pouring the mixed batch into a second bucket and then mixing again. This ensures that you will not have any unmixed resin trapped in the sides and bottom of the bucket. With the resin mixed, it's left to stand for a minute for the worst of the bubbles to escape, and the feed lines are then secured into the bucket with tape.
So we've got absolutely no air in this side of the bag. There is, however, air in these lines here. So what I'm going to do is just gently open the line, allow it to draw the resin through to this point, and then the air that's there, I'll wait for another minute or so, that can get drawn away, and it just saves us whisking the first bit of resin with the air that's in these lines. You can see there, and then it hits the stop of that, because you don't need to unclamp it all of the way. And we'll do the same on this side. So just slacken it off. Resin draws through, hits the clamp, and then stop.
The line clamps are now removed and the resin is allowed to be drawn into the part. Immediately, you will see the resin flow down the spiral and into the mesh and reinforcement. Don't worry if you see a few small bubbles rushing forward on the leading edge of the flow. This is normal, especially with resin that hasn't been degassed. It's simply the microscopic air bubbles in the resin expanding exponentially as they approach the near absolute vacuum in front of the flow. Although this should never happen if you've done a thorough drop test, if you do see a stream of bubbles emanating from one point in the bag, it is possible to plug the leak with some sealant tape as the part is infusing. It is worth noting it's not always easy to track down the source of the leak, and this should never be relied on as a method of fixing a leak that you knew was there before starting. The best way to ensure that the part has had the right amount of resin is to calculate the amount of resin that the part will need, accounting for the reinforcement, the cores and the mesh, and then shut the line off when it has used this amount. We have information about this calculation on the project page on our website. Another method is to simply close off the feed line once the infusion has completed. Although this might sound quite inexact, the infusion process self-regulates very well, and for one-off and non-critical parts it's perfectly acceptable practice. Likewise, if you're unsure of the amount of resin that will be required for a part, it's absolutely fine to make a few small batches of resin and top up the feed bucket as you go. While we plan to cover some more advanced infusion techniques in future videos, for this part we have used the most simple infusion stack of materials. This is incredibly reliable and has served industry well for decades. However, here at Easy Composites we do have many other materials, not only for infusion but for many advanced composite processes. So please take a look through our website if you're not already familiar with our range.
You can really see here the effect that the resin brake has. It's slowing down the resin, and if we hadn't have put it in place here, this resin now would be following this line up and would already be on the vacuum port. So we'd be pulling out resin at this stage before this area is finished infusing. But fortunately, we have put it in and we still have a clear air path to this section.
With the part fully infused with resin, we can clamp off the vacuum line and switch off the vacuum pump. In this instance, we need to wait a few minutes longer for the correct amount of resin to be consumed by the part before clamping off the feed lines.
This has now been left at room temperature for 48 hours to reach full cure, so we're ready to strip off all of the bagging materials and demould. A really good indication as to whether the resin is adequately cured for a demould is if you take the resin feed lines full of resin and give them a flex, you should get a clean, crisp crack and break in the resin. If it just flexes, that means your resin is probably not cured far enough, so you might want to leave it a bit longer.
Tearing out the peel ply and mesh can be quite tough going, but cutting it into thin strips does make it much easier. Many of you who are familiar with the infusion process will know that a perforated film can be used instead of or behind the peel ply to make the removal much easier. This, however, does come with its slight compromises, which we will cover in a future video.
Right, so the moment of truth, let's get this sledge out of the mould.
Proper mould design and release agent application should mean that the release is very straightforward and should only require very light pressure to break the vacuum seal.
So this is the final part out of the mould. I'm really pleased with how it's turned out. All we've got to do now is take it through to the booth, mark it up and trim it, and then it'll be ready to be sent off to be fitted out.
Kevlar is not only tough to cut as a dry cloth, but also as a finished laminate. The cut line will invariably fluff up. I find that the easiest way to clean up the trim line is to sand it into shape with a permagrit block, and then remove the fluff with a fine 800 grit wet and dry paper.
So here we have the completed shell. I now need to go on and make another 2 of these, as there are 3 members of the expedition team. Then we're going to get this loaded up and run over to the guys at Alp Kit, who are going to finish it off with the covering. These are now back from Alp Kit. I'm sure you'll agree that they've really come together with the covers and the decals. They look like the finished product. Alex is on his way down and I'm really excited to see what he thinks of them. Right, so what do you think of them? I'm pretty pleased with how the end products ended up.
Oh, it's looking absolutely brilliant. It's amazing to see it, first of all, on a screen all those months ago, and then suddenly it's the finished product.
Yeah, certainly.
And it looks as tough as any of these I've ever seen in my time. I've seen them designed by different people, different parts of the world, but I think this is going to be able to take as much abuse as we can throw at it.
Yeah, well, I've got my reputation on the line on this one, but I'm pretty confident that these will be able to take any abuse that the Arctic will have to throw at them. Yeah. So where are these going next?
So the idea is we're going to be getting this on the ice at the end of this year. So this winter, it'll be going up to hopefully the high Arctic, but if not, just sort of the subarctic regions. And so we can really test it on location and make sure that it ticks all the boxes.
Fantastic. Well, that's the last we're going to be seeing of these sledges, or at least the last I'm going to be seeing of them. I really hope you've enjoyed this video series. If you do want to learn more about composites, have a look through our back catalogue of videos where we've got a wide range of different manufacturing processes covered. Now, we are producing new content all of the time, so hit subscribe if you want to be notified as and when we release that. And as ever, a massive thank you to all of our customers who make producing these videos possible.